All right, so let's find the eigenvalues of a 3 by 3 matrix here. Okay, so it's really a general topic, but it comes with the practice. You have to practice a lot of problems. So let me do an example. So it's the same process. We first start with writing the A minus lambda I matrix. So which is negative 1 1 0 1 2 1 0 3 negative 1. Okay, minus lambda times, now this is a 3 by 3 matrix, 3 rows 3 columns, so you need 3 by 3 identity matrix. That means 1 along the diagonals, everywhere else you have 0. Now the next step is to simplify this and write it as a 1 matrix, right? But before that, let's multiply that lambda, and we get lambda 0 0 0 lambda 0 0 0 lambda. So this is identity times the lambda. So now if you shrink this into a 1 matrix, what you get is negative 1 minus lambda 1 0 1 2 minus lambda 0, oh not 0 here, 1 minus 0 is 1. Okay, you subtract these two, okay, element by element, corresponding element by corresponding element. Here 0 3 negative 1 minus lambda. So this is the A minus lambda I matrix. Now what you do is you find the determinant of this matrix. So what I do is I take the first row, I go column by column, but feel free to do it in your own way. So first I take the first element, negative 1 minus negative lambda times the determinant of this part, right? These two, this matrix. So 2 minus lambda, negative 1 minus lambda minus 3. Then you take the second number, but by default here it's negative, times 1 times. So now you forget about the second row, second column and the first row. The determinant of the rest, 1 times negative 1 minus lambda is negative 1 minus lambda, 0 times 1 is 0, minus 0. Plus by default here times 0, the third element times, well, it doesn't matter, everything else doesn't matter because you multiply by 0, right? Should be equal to 0. That's, we know, right? Determinant should be equal to 0. We discussed this in the previous video. Alright, so my rule of thumb is please simplify what you have here. Okay, do it carefully. So here I would like to take a negative out because I don't like negatives everywhere. So it's 1 plus lambda. Okay, negative times 1 plus lambda. If I rewrite this term inside the bracket, before you expand this bracket, please simplify whatever you have inside the bracket. Please expand the brackets inside the brackets. So here 2 times negative 1 is negative 2. 2 times lambda, negative 2 lambda, plus lambda, minus lambda, plus lambda square, minus 3. Here nothing to expand, right? Here it's just 0. So negative 1 times negative 1 minus lambda is 1 plus lambda, right? So that's we have. So let's write it nicely, beautifully. Plus here I would have a bracket for this term. It's 1 plus lambda. Okay, it's nice to have brackets like this. Okay, I will show you the advantage in a minute. Now simplify this furthermore. So here inside the brackets it's lambda square minus 2 lambda plus lambda, negative 2, negative 3, negative 5, plus have these brackets. Now why do we have these brackets? Now here you have a polynomial, you have to find the roots of this. Or ideally the way you would do is, here this is a third degree polynomial, right? Because you have a 3 by 3 matrix, you should have a cubic polynomial. How do you factorize it? You don't have a quadratic formula, right? Quadratic formula is for quadratic functions. Now notice carefully, why did I ask you to have parentheses for terms? Isn't this term common? So let's take out a 1 plus lambda from the whole expression. Okay, so what do we get? Negative lambda square minus lambda minus 5, plus when you take a 1 plus lambda from here, it's just 1. Okay, this is not a trick that will work for every time you do a 3 by 3 matrix, but this is one of the tricks. Otherwise you should be able to find the roots. Okay, all right. Now here 1 plus lambda, let's simplify this furthermore. So negative lambda square plus lambda plus 5 plus 1. Okay, I distribute the negative here. So this is actually 1 plus lambda, negative lambda square, plus lambda plus 6, right? Oh, we do have a negative outside, right? Oh, no, we don't. My bad. Forget about that. Okay. Anyway, so now we can factorize this quadratic equation. So if you can factorize that quadratic equation, okay, here what you should get is lambda minus 3, okay, lambda plus 2. All right, so let me double check, and a negative in front of if you factorize this one. Okay, or you can write this as the same thing as you can take a negative out, lambda square minus lambda minus 6. This can be factorized as lambda minus 3 times lambda plus 2. Okay, so we get this polynomial fully factorized. That is exactly what you need to do when you have a 3 by 3 matrix. Okay, so what are the eigenvalues? So from here lambda 1 is negative 1, from here lambda 2 is 3, from here lambda 3 is negative 2. So these are the 3 eigenvalues for the matrix that is given here. Okay, all right, so that really comes with the practice. Try to solve the problems in your note, try to do them by yourself always. Okay, always try to find the eigenvalues by yourself. When I do the video, try to pause it, try to do it by yourself and compare with what I have. Okay, all right, so that is how you find an eigenvalues of a 3 by 3 matrix. Really, it's just one example, but when we move on, we will do lots of examples. Okay, then you will see more. All right, then yeah, thank you very much.